Hey, welcome back to Math with Patrick and Quill. Today is December 9th, and we're solving problem 343 from the Daily Epsilon calendar. And the answer should be 9 because that's today's date. So we need to find the net percentage loss of an investment that increases by 30% and then decreases by 30%. All right, let's try solving it 3 different ways. How about? The first way is we could just assign a value to our investment, and let's just pick $100 because that seems like an easy, reasonable value. And we can just compute the 30% increase and decrease directly on this value and see what happens. So if we do a 30% increase, we can do one of two things. Either we could just multiply by 1.3 or 1.30. This right here is the same 30 as the 30% increase. This is my preferred method. Or you could think about finding 30% of your initial investment. We could multiply by 0.3 for that, and then just add it on to the original amount. Now, if you do it this way, you could just factor the 100 out, and then we do get 0.3 plus 1. The 1 is coming from the 100 that's already here, and essentially both of these strategies are the same in the end. I do prefer the first one because it's one step instead of two. Anyways, finding a 30% increase on $100 is not hard. That's just $130. What's a little bit trickier is doing the mental math for a 30% decrease on $130. And here we could do it 2 different ways. Again, we could either multiply just by 0.7, or like the reason why this 0.7 makes sense is we can take our initial value and subtract 30% of our initial value. And here we can factor out the 130 and we get 1 minus 0.3. That's where I'm getting this 0.7 from. And to multiply these, I think what I'll just do is 13 times 7 and then deal with the decimal point later. This is 21 plus 70 or 91. And just kind of like number sense, it does make sense that 70% of 130 decreases that to $91. So in the end, we had $100, or rather we started with $100, and then in the end, we are left with 91. So we can see that this is a 9% decrease because $9 is 9% of 100. So that's kind of why I chose 100 to begin with, because we'll also see the 9 in our answer as well. So this is a decrease of $9, and so this is the same thing as a 9% decrease, and we're done. Way number 2 is that we don't really need an initial value. We could just say X for our initial value, or maybe P for principal amount. And then we could do that same thing where we multiply by 1.3 for a 30% increase. We can multiply by 0.7 for a 30% decrease. Multiplying these two numbers together, it's still 13 times 7, and so I will get some kind of 91 idea out of this. Although I know that when I multiply two numbers that are roughly 1, that I should get an answer that's about 1 as well. So, or we could just look at the decimal points too. Either way, multiplying these two together does give us 0.91. And so the 30% increase and the 30% decrease is the same as multiplying by 0.91. And we can kind of extract that 9% decrease by thinking of it again as 1 minus 9%, or 1 minus 0.09. Okay, the last way to think about it that I wanted to share is essentially just the same thing as way number 2. Although you can compute these kind of percent increase then decrease problems maybe a little bit more quickly if you think about it as a difference of squares. For example, here we are doing 1 plus, say, 3/10. And then when we're multiplying by the 30% decrease, that's 1 minus 3/10, or 30 over 100 to make it look like 30%. Either way, when we multiply it all out and we FOIL our binomial, the outside and inside terms cancel out. And so we're just left with the square of the first term minus, and then the square of the second. So we get minus 9 over 100. And so if you had a different problem that had an increase of some percent and then a decrease by another percent, there is some idea of essentially just squaring that value, and then you'll get the answer. Just to show you another example, let's say it was a 25% increase and then a 25% decrease. I could think about it as maybe plus 1/4 and then minus 1/4. This is just going to be 1 minus 1 over 16. And then this would give me the percent decrease percentage if I converted it to a percentage. Anyways, that wasn't really important for today's problem. What was important was this 9 right here, because this is a 9% decrease. Percent, again, is kind of like divide by 100, and then the subtraction sign is indicating a decrease in value. So those are the 3 things I wanted to show, and I'm thinking I'm all done. So here's the 9 for our answer, or maybe it's that one right there, or maybe it's that one right there. Overall, we do get a 9% decrease. So we're all done. Hope you enjoyed. Thanks for watching, and I'll see you tomorrow. Bye.